Hi everyone, I am Shaktiver, Assistant Professor in the Sun College of Engineering and Technology, Coimbatore, and today we are going to see about the cement as a building material. Cement is a fine soft powder and it has been used as a binder because it hardens after contact it with the water, and it is produced from by the mixture of limestone and clay that has been charred and then ground up. The various ingredients of cements that includes the limestone, CaO, silica, SiO2, and alumina, Al2O3, and magnesia, MgO, iron oxide, Fe2O3, and calcium sulfate, CaSO4, sulfur trioxide, SO3, and alkaline that indicates that NaOH twice or maybe of a KaOH twice. The chemical composition of the cement that includes the lime 60 to 67 percentage, since it indicates that binding property, and in our olden times we have been used only with the lime concrete, or maybe of a lime has been used for a plastering and then other purposes in a constructions. So in the manufacturing of the cement we have been used 60 to 67 percentage of lime and 70 to 25 percentage of silica and 3 to 8 percentage aluminum and iron oxide as a 0.5 to 6 and magnesium oxide as a 0.124 and sulfur trioxide as 1.3 to 3 percentage, alkalis 0.4 to 3 percentage, and the gypsum, that is the calcium sulfate, 3 to 4 percentage. Next one, just we are going to see about the role of oxides in a cement. So it indicates that first thing lime CaO. In case of a lime, the excess lime that makes the cement as an unsound and causes the cement to expand and also disintegrate. And thus, if it is in a deficiency, the strength of the cement has been decreased and the cement sets quickly. And thus, it should be in a right proportion that to produce the cement sound and also with the strong. Next one, silica and SiO2, it imparts the strength to the cement and in an excess provides the greater strength to the cement, but at the same time prolongs the cement setting time. And the alumina Al2O3, it imparts the quick setting quality to the cement, lowers the clinkering temperature. So the clinkering temperature will get slow, and then in excess it reduces the strength of the cement. And then iron oxide Fe2O3, and iron oxide provides the color, hardness and strength to the cement. Role of oxides in cement. It indicates that magnesium oxide, it imparts the hardness and color to the cement, and in an excess makes the cement unsound. And the sulfur trioxide, it makes the cement sound, and in an excess it causes the cement unsound. And in alkalis, in an excess it will cause the efflorescence. And the calcium sulfate controls the initial setting time of the cement, that is CaSO4. Setting action of cement. When the water has been added to the cement, the ingredients of the cement react chemically with water to form the various chemical compounds. There are the few compounds formed during the setting action of cement called the Bogue's compound. The Bogue compounds. Oxides that has been present as a raw material in the production of the cement when subjected to a clinkering temperature that has been of a high temperature combined within each other to form the Bogue compounds. The compound name, formula, abbreviated formula and literature name has been given here. One will be of a tricalcium silicate, dicalcium, tricalcium aluminate, tetracalcium aluminoferrite. So C3CaO, the CaO indicates that calcium and SiO2 indicates that silicate. So tricalcium, that is 3CaO and 1 SiO2, it indicates that C3S, and literature name as an halide. And the dicalcium silicate 2, di means 2, 2CaO and SiO2, it is of a C2S, the literature name has been of a belite. And tricalcium aluminate, that is tricalcium 3CaO and 1 Al2O3, C3A selite. And tetracalcium aluminoferrite, that is 4 calcium, 4 CaO and 1 Al2O3 and 1 Fe2O3, which indicates that C4AF, that is of a phthalate. And in a previous cases that we have been seen the 4 components C2S, C3S, C3A and C4AF. So in a reverse we are going to take it as C3A and a C4AF that has been formed within the 24 hours after the addition of a water to the cement. So which means that initial setting time and final setting time that has been calculated by the C3A and C4AF, and C3S formed within a week or so after addition of water with the cement, and it is responsible for imparting strength in the early period of setting. So we have been testing the concrete cubes on a seventh day. So C3S has been formed within a week, so that the seventh day test indicates that the formation of a C3S, and the C2S formed very slowly, and hence it is responsible for giving a progressive strength to the cement, which indicates that the strength of the cement increases with day to day. It does not depart. So which means that the C2S is the mainly responsible for forming the strength to the cement. And this is the overview of the manufacturing of cement. It indicates that from the excavator, that means of a clay, limestone, and sand, it has been excavated and has been transported to the conveyor, and it has been moved to the crusher and then secondary crusher, and it has been moved to the proportioning equipment. That has been proportioning equipment indicates that proper mixing of the sand, clay, and also with the limestone moves to the grinding mill, and then go to the preheated tower to the clean, and from that the clinker has been manufactured and the clinker has been cooled, and by the addition of the gypsum we are going to grind the clinkers, and then the cement has been stored and moved for a packing and also for the shipping. This is the overview of the manufacturing of the cement, and the in-depth analysis will be as follows. And manufacturing of cement. So the manufacturing of cement that involves the various raw materials and process, and each process has been explained chemical reactions for the manufacturing of the Portland cement, and thus the cement is a greenish gray color powder made of the calcinated mixture of a clay and also the limestone. When mixed with the water, it becomes hard and a strong building material. And the history of this cement goes back to the Roman empires. The modern day cement, that is, the Portland cement, was first produced by the British stonemason Joseph Aspdin in 1824, who cooked the cement in his kitchen. He heated a mixture of limestone and a clay powder in his kitchen and grind the mixture into the powder, creating a cement that hardens when it mixed with the water. And the name Portland was given by the inventor as it resembles a stone quarried in a isle of Portland. The first use of modern day Portland cement was in the tunnel construction of a Thames River in 1828. The Portland cement has a various procedures in the manufacturing of the cement, and the procedure is as mixing of a raw materials, burning, grinding, and final stage as a storage and also the packing. Thus, the mixing of the raw materials. The major raw materials that has been used in the manufacturing of the cement are the calcium, silicon, iron, and the aluminum. And these minerals are being used in the different form as per the availability of the materials. The table shows the raw materials for the Portland cement manufacturing. And the calcareous material that includes the calcium. The calcium stones that has been of a limestone, marl, calcite, argonite, shale, seashells, cement, clean dust, and this includes the calcium. And also that argillaceous materials includes the silicon, aluminum, and iron. So the clay constitutes of the both silicon, iron, and the aluminum, and marl, sand, shale, fly ash, rice husk ash, slag. This includes the silica, and the aluminum, shale, fly ash, and aluminum ore refuse are includes the aluminum, and iron ore, mill shale, blast furnace dust. This includes iron ore in it. We are having two methods of mixing of the raw materials. One is the dry process, and another one is a wet process. And the flowchart gives the dry mix for the manufacturing of the cement. It includes the calcareous material and the argillaceous material. Both of them has been crushed separately, and then it has been grinding by using the fine grinding in a ball mills and also with the tube mills, and then it has been stored in a basins, and then it has been mixed in a proper proportions, and then preheating to the 800 degrees Celsius by an exact gases, and then stored in a tank for a raw materials, and then it has been fed to the rotary kiln, and then in case of in the kiln, the clinkers has been formed, and in the clinkers, by adding the 2 to 3% of the gypsum, the clinkers has been grinding in a ball mill, and it has been stored in a cement silos, and then we are going with the packing of a cement. In the dry process, the both calcareous and the argillaceous raw materials are firstly crushed in the gyratory crushers to get the 2 to 5 centimeter size pieces separately. and the crushed materials are again grind to get the fine particles into the ball mill or a tube mill. Each finely grinded material that has been stored in a hooper after the screening, and now this powdered minerals are mixed in a required proportion to get the dry raw mix, and which is then stored in a silos and kept ready to be sent into the rotary kiln. Now the raw materials has been mixed in the specific proportions so that the average composition of the final product is maintained properly. And in case of a wet process, the raw materials are firstly crushed and made into a powder form and stored in the silos. The clay is then washed in a wash mills to remove the adhering and the organic matters found in the clay, and the powdered limestone and water washed clay are sent to flow in the channels and transferred to the grinding mills where they are completely mixed and the paste has been formed, and this paste is known as the slurry. And the grinding process can be done in a ball mill or tube mill or even both. Then the slurry is laid into the collecting basin where the composition can be adjusted, and the slurry contains around 38 to 40% of water that has been stored in a storage tank and kept ready for the rotary kiln. The comparisons of the wet process and the dry process includes the hardness of the raw material. Dry process quite hard, and it may be of any type of raw material in case of a wet process. And the fuel consumption, dry process has been low and the wet process has been high. And dry process has been less and the wet process has a higher time process. And the quality, dry process has a inferior quality and wet process has a superior quality. Cost of production, dry process has a high cost of production and the wet process has a low cost of production. Overall cost, dry process gets costly and wet process gets cheaper. And in a physical state, raw mix, that is the solid mix, and in case of a wet process, that will be of a slurry mix. And next one, it is a burning of the raw materials. So the burning process has been carried out in a rotary kiln, while the raw materials has been rotated at around 1 to 2 rotations per minute at its longitudinal axis. The rotary kiln has been made up of a steel tubes having a diameter of a 2.5 to 3 meters, and the length differs from 90 to 120 centimeters. The inner side of the kiln has been lined with the refractory bricks. The kiln is supported in a column of a masonry or a concrete and rested on a roller bearing in a slightly inclined position to the gradient of 1 in 25 or 1 in 30. The raw mix of a dry process or correlated slurry of a wet process is injected into the kiln from the upper end, and the kiln has been heated with the help of the powdered coal or oil or hot gases from the lower end of the kiln so that the long hot flames has been produced. As the kiln position has been inclined and it rotates slowly, the material charged from the upper end moves towards the lower end at the speed of 15 meters per hour. In the upper part, water or moisture in the material is evaporated at a 400 degrees Celsius, and so that the process is known as the drying zone. And the central part, that is the calcination zone, the temperature has been around 1000 degrees Celsius where decomposition of the limestone takes place. The decomposition, it indicates that CaCO3, which gives the CaO and CO2. The remaining material is in the form of the small lumps that has been known as the noodles after CO2 has been released. And the lower part, that is the clinkering zone, having a temperature in between 1500 to the 1700 degrees Celsius, where lime and clay are react to yielding the calcium aluminates and the calcium silicates. The aluminates and silicates of the calcium fuse together to form the small and the hard stones that has been known as the clinkers. And the size of the clinker is varying from 5 to 10 mm, and the lower part, that is the clinkering zone, has a temperature around 1500 to 1700 degrees Celsius. In this region, lime and the clay react to yield the calcium aluminate and the calcium silicates. This produces the aluminates and the silicates of calcium that has been fuses together to form a hard and the small stones that has been known as the clinkers. The size of these small and hard clinkers varies from 5 to 10 mm, and in this process there are the four compounds of the Bogue compounds has been formed, and the clinker coming from the burning zone are very hot. To bring down the temperature of the clinkers, the air is admitted in the counter current direction at the base of a rotary kiln. The cooled clinkers are collected in a small trolleys, and this is the rotary kiln process for the wet process. And in these cases, this is the dry zone, and this is the media that has been noodles has been formed, and this is the lower zone that clinkers has been formed. And in these cases, outer surface, in the inner surface has been of a refractory lining that has been made up of a bricks, and from the storage tank this slurry has been inletted in a dry zone, and the noodles has been formed here, and in the burning zone up to the 1000 degrees Celsius. And in the final stage, the clinker has been formed at a 1500 to 1700 degrees Celsius, and the here the air has been formed, and that air cools the clinker, and then it has been moved to the cooler, and we can collect the clinkers in a trolley or any other material. And this is the flow trial for the clinkers. Next stage, it includes the grinding of the clinkers. The cooled clinkers that are received from the cooling pans are sent into the mills. The clinkers are grind finely into the powder in a ball mill or a tube mill. The powdered gypsum has been added around 2 to 3% as a retarding agent during the final grinding. The final obtained product is the cement that does not settle quickly when it comes in contact with the water by adding the property of the gypsum. After the initial setting time of the cement becomes stiff, and the gypsum retards the dissolution of a tricalcium aluminate by forming the tricalcium sulfoaluminate, which is insoluble and prevents two early further reactions of the setting and the hardening, and this chemical reaction has been given here. The grinded cement has been stored in the form of the silos, and from which it has been marketed either in a container load or maybe of a 50 kg bags. I hope you understand this video. Thank you.